Hey everybody, it's Mr. Carr again. Today we're going to be looking at 7.4 day 2, calculating what's called z-scores. So z-scores are going to help us understand a little bit better about where are we at in terms of a curve on a normal distribution. So let's take a look at this as a quick example. If you were to look at this and look at somebody's math scores and English scores, you might say, if I ask you to answer the question, who did better? Or sorry, which test was better for the student? Now, I would probably say, if you look at it just this, the math score is greater than the English score. So I would say it's probably because you would probably choose the math test on that one was probably a better test. Okay. But if you compare how much above the mean that you scored, well, take a look at this. The mean was 80%, and then you scored 5% above. Here, the mean was 73%, and then you also scored 78%. So it's also 5% above. So is there really a better one? Like you did better than average in both cases, but in math, like math, you were 5% more, in English, you were also 5% more. So to the rest of the classmates, both scores were 5 points above the mean. Okay. So these are things that are helpful to kind of get a feel for it. But what about the standard deviation? Standard deviation here is 4, and this one's 2. So remember what we're saying with that. So for a very brief little curve here, so this is going to be math. Math, we're at a mean of 80, and then a standard deviation of 4. So we would do like one standard deviation is 84, second standard deviation is 88. So where's 85 on that? 85 is just a little bit beyond here. So if you think about the percentages, okay, um, with those percentages, you are just a little bit above one standard deviation, okay? But when we do English, draw my little curve here. The average was 73. If the standard deviation is 2, that's going to be 75, and then 77, and then 79. It's not drawn to curve. It's not drawn to scale on that one. So a score of 78 in this case, with a standard deviation of 2, puts me here. Okay, it puts it more than two standard deviations above the mean. So when you look at it that way, especially comparing to the peers here, the English test scored, yeah, scored better than more classmates. Okay, if we are just a little bit more than one standard deviation above, remember this is 50% below the mean, then this is another 34%. Okay, so you've done better than 84%-ish. Like maybe basically, you scored higher than 84% of your classmates here. But in English, this is 50%. This is 34%. 34 here. The second standard deviation is 13.5. So it's a little bit more than that. So you're looking at 84. You're scoring better than, was it, 97.5% of your fellow classmates here? So you're scoring, like that's what we're referring to this. Now, we can be more exact with this. That's what the idea is, what we're going to find here. So the empirical rule is helpful for analyzing data values in specific locations, like if you are 1, 2, and 3 standard deviations above or below the mean. But what if those data values are at other locations? So we're going to use the idea of standardizing the data. We're going to calculate what's called z-scores. Okay. These are representing the number of standard deviations that a given data value is from the mean. So therefore, we can determine the location of any data value within a set of data. So what we mean by that is our z-score here is going to equal to the data value minus mu, which is the mean, divided by my standard deviation. Okay? So all this information will either be given to you, or if you think back to when we did this in before, you can get everything from one variable stats. So if you're given some set of data, you can actually find a lot of this too. So find the z-score for this right here. x equals 18, mu is 22, and standard deviation is 3.1. So z is equal to 18 minus 22 divided by 3.1. Now, the order of this formula does matter because negative z-scores are different from positive z-scores. So I plug this in my calculator. So 18 minus 22 divided by 3.1, I get a negative 1.29. Okay, so we're going to always use two decimal places here whenever we do this. Now to kind of draw a quick label here, again, the mean is right in the middle. That's going to be 22. Our standard deviation is 1.29 to the left of this value. So one standard deviation will put me here roughly. So this is going to go beyond here. So that's what we're looking at, like that part right there. Okay, so z equals a negative 1.29. It is 1.29 standard deviations below the mean. Okay, so that's where the 18 is. Now, one standard deviation below would have been 3.1 less than the 22 here. So that would have put me at 18.9. So you can kind of see that makes sense. 18 is to the left of 18.9. So is that negative 1.29. It's just beyond that one standard deviation. Okay. We'll just do that again. Find x now. So we're going to change this up a little bit. So one thing I like to do is if z-score is equal to x minus the mean divided by standard deviation, I'm going to change this formula up a little bit. I'm going to start by multiplying both sides by the standard deviation. That will cancel that out. So standard deviation times z is equal to x minus the mean. And finally, I'm going to add the mean to both sides. So x is going to equal to standard deviation times z plus the mean. So now I have this brand new formula basically. Now I'm just going to plug in my numbers here, here, and here so I can find my x value. So x is equal to, that'll be 8.2 times z-score, which is 0.73. And then there'll be plus the mean, which is 39. So x comes out to 44.99. So my interpretation of here is just telling us that the x value that is 0.73 standard deviations above the mean is 44.99. Okay, so again, here's my mean goes in the middle, that's 39. One standard deviation would put me here, and that would normally be 8.2 more, so that would be 47.2. But we're trying to represent the 44.99 because that is less than a full standard deviation. So it's about right there. Z is equal to a 0.73, which is related to an x value of 44.99. Okay. All right. I think, yeah, one last example here. Find the standard deviation if all of this is given. Again, I'm going to start with my z-score formula where x minus the mean divided by my standard deviation. I'm going to rearrange this so I can solve for standard deviation. So one thing I'll do is multiply both sides by sigma. So sigma z is equal to x minus the mean. And then honestly, I just divide by z to both sides. So sigma is equal to x minus the mean divided by my z-score. All right. So in this case, I'm going to do x is 125 minus the mean of 100 divided by 2.15. So when I do that, that's going to come out to 11.63. Okay. So in this case, whoops, hello. The mean is right in the middle. That is 100. Standard deviation is 11.63. So that'll be like 111.63. And then this will be 123.26. And then, oops, I'm just a little bit beyond that to get to my 125. Well, a little bit closer, like right here. Okay, so that's a z-score of 2.15, which puts me at an x value of 125. Okay, so again, just visually looking at what did the z-scores mean in terms of my normal curve. Okay, how far to the right does it push? How far to the left? It is always in terms of standard deviations. So we're just looking at instead of just one, two, or three whole numbers, we're looking at these decimal numbers that are either above or below my mean. Okay. And that is it for today. So again, finding that's using the z-score formula here we're using that to find our z-scores and then interpreting that on a quick little bell curve. All right. Take care, everybody.